然后呢，接下来呢，我们会就是邀请到讲者是我们在 Mozilla 的 Andreas Gal。那他目前呢，就是在 Android 致力于就是 Web 的各项系统层面的一个发展，包含一些行动作业系统方案 Boot to Gecko 等等。那他等一下呢要分享的题目是 Gaia a modern smartphone user interface in HTML5 and JavaScript。那麻烦就是请大家掌声鼓励，谢谢。
All right. Sorry for the technical problems there. Looks like we can get started. Okay, my name is Andreas Gal. I work for Mozilla, and I'm the Director of Research and Development. And my group does a bunch of different researchy and development projects for Mozilla. So basically, the goal of my group is to identify things you cannot do with the web, and then find out why you cannot do that, and then go and fix that. And about a year ago, we decided to find out why mobile phones or cell phones or in general mobile devices are not really built with the web. If you look at the desktop, almost everything on desktop happens with the web. It's very rare these days that people make software for Windows 32 APIs. Everything is delivered with the web, and for some reason phones and mobile devices work very differently. So we just set out to find out why, and as part of that we started to build a project called Boot to Gecko, and that's what I'm going to talk about today. And I will start with the motivation, kind of explain to you why I think that it's so strange that we have Android and iOS, and why I think that doesn't really make sense to me. Those things should not be around, they really should be just the web. So let's talk about that a little bit. So first of all, I'm not sure how many of you know Mozilla. We have a very interesting history. So Mozilla is a non-profit entity. We are very distributed and global. We are in many different countries, amongst others here in Taiwan. And the main thing that people know us for is Firefox. It's the web browser product we are making. And we have, when these slides were made, we had 450 million users. I think now it's closer to 500 million. We are localized in a lot of different languages. And the Mozilla Foundation, which is the non-profit entity that really is Mozilla, actually also owns a company, the Mozilla Corporation. And that company has over 650 employees. So again, these slides are a little bit out of date. I think by now we have around 700 employees. And we have subsidiaries in 15 different countries. And this is just the core of Mozilla. This is basically the Mozilla Foundation itself and a bunch of people the Mozilla Foundation employs to work on Firefox. But around that is actually a much larger community of people. So there's thousands of people who actually help us develop Firefox. And there's probably a couple of people in this room as well who have contributed to Firefox. And in addition to that, in addition to the actual core of Firefox, where people build the browser itself, there's also a very large community of building add-ons. So we have more than 140,000 add-ons people built. These are things that you can build to customize the browser with, and you can build small little code snippets that make your browser behave in a certain way that you would like. So we don't do all the customization ourselves. We don't have to build a browser that does everything that you want to do. What we do is build a platform for you, where you can go and customize it the way you like. And much of that is done in JavaScript as well, so that's a very popular way of extending Firefox. And that's also being built by thousands of contributors. Now, Mozilla's history goes back more than 10 years ago. So more than 10 years ago, there was a company called Netscape that made pretty much the first commercially successful browser. And Netscape's business model was that they were making a browser as a closed source proprietary software product, and they were giving it out for free for people to use, and that's how the web really started growing. Suddenly the web, instead of just doing FTP and Telnet, which are really boring ways of interacting with the web, became this like lively thing that you can touch and colors, and it was much more interesting. So Netscape gave this browser away for free if you were a private user, but they charged you money if you're a company. And this worked pretty well in the beginning until Microsoft decided to make a browser as well. And at that point, this entire model stopped working because Microsoft made the browser as well. It was also closed source. Microsoft made it, and Microsoft gave you the binary. But then Microsoft gave away that browser completely for free. That was Internet Explorer. And this, of course, was very difficult for Netscape because Netscape was deriving its money from selling Netscape, the Navigator browser. And Microsoft did not need the money from IE. They just were making money on Windows. So very quickly, Netscape disappeared from the marketplace. They went bankrupt, more or less. And as Netscape was kind of dying, one of the last dying acts of Netscape was to create the Mozilla Foundation. And there was a very interesting rationale behind that. Netscape observed that you can't really compete on the web, making a web browser, until the web is really open and completely based on open standards. So what Netscape ran into that Microsoft very quickly started to get a lot of market share, and Microsoft started expanding the web with Microsoft-only technology. A very famous example for that is ActiveX. Who here has ever heard something of ActiveX? I've heard of ActiveX. Anyone else here, ActiveX? So actually, here in Asia, it's still in use a little bit more than it's in other parts of the world. And it's a horrible piece of Microsoft technology. It's completely non-standard. Only Microsoft can implement it. So this is actually often a problem still to this day for Firefox in some Asian markets, and particularly in mainland China, where ActiveX is still being used because we can't implement it. Nobody knows how it works. Only Microsoft knows how it works. So based on this observation that Netscape made 10 years ago, as they were kind of dying, they realized that they have to make sure that the web is open and that everything is implemented based on open standards, because only then can others implement the same standards. And this led to this core mission of Mozilla, that we want to give people choice. So Mozilla makes Firefox. For us, we like it when you use Firefox. But what's even more important for us is that you have choice. You can decide what you want to use. You don't have to use Internet Explorer. There's a couple other options for you. So this is the history of Mozilla. And over the last couple of years, it turned into a very strong success. So now around 30% of the people using the web, using Firefox to browse it, and in many countries, we are the #1 browser, amongst others in a couple of European countries. Now, compare the web today with what it was 10 years ago when its journey started. So I'm not sure how many of you here have used ever the really old versions of Internet Explorer, right? IE6. That was really a miserable experience. The web really sucked back then. You could barely look at documents, and everything was slow, and it was crashing all the time. And the browser had very few capabilities. You could display a document, kind of, sort of, and you could render some fonts. But a lot of the cool stuff that's part of the web today, you couldn't do with IE. And it was pretty obvious why you couldn't do that, because, first of all, Microsoft was the only party that could implement many of the standards in IE6, such as ActiveX. And also, there was no competition. There was basically only IE. 98% of people back then when IE6 came out were using Internet Explorer. So Microsoft was under no pressure to really make the web better, because people were using their product anyway. So compare that today. Today, everything is really, really different. So today, most web pages that you go to are based on open standards. There's very little ActiveX use in most parts of the world, for example. And there's no longer just one browser, Internet Explorer. There's many, many browsers now. So there's Firefox, obviously, which we make, but there's also Chrome, and there's Safari, and there's Opera, which is a little more popular in Europe than here. But then also, actually, there's IE. IE is back. IE has a new version, 9. And that browser is actually much, much better than IE6. So even Microsoft suddenly had to go back and write a good browser, which they for many years just didn't feel was necessary. So how did this happen? How did we get from really crappy web to awesome web with many browsers? So Mozilla actually had a really big part in that. This goes all back to our mission. So our mission is to make sure you can choose. You can decide what browser to use. And then ideally, we really like it when you choose Firefox, but that's kind of a secondary goal. The primary goal is for you to make sure you actually have a choice, first of all. And as I already said, the key thing for that is interoperable standards. If it's not based on standards, there's no real choice. Because then someone like Microsoft can go ahead and implement some other ActiveX thing, and only Microsoft knows how to implement that. And if sites start using that, then you can only use a Microsoft browser to go there. So really the only way to ensure that you can use whichever browser you like is to make sure that all the browsers implement the same technology. This is, of course, also really nice for content providers, because if you're creating a website and you base everything on open standards, then suddenly you write your code once and it runs across all these different browsers and all these different devices. But it's actually a very nice other effect of this. So to explain that to you, I'm going to use a little example here. So you see here on this rather blurry screen here, a benchmark graph. So over the last 3 or 4 years, the different browser vendors have been in a very vicious performance game. Everyone is trying to build the fastest possible browser. Why are we doing that? Well, first of all, we want to build a fast browser, that's for sure. But also, there's competition. The press likes writing about benchmarks, right? Every time a new version of Chrome comes out, they run a benchmark, and then Chrome is really fast here, Chrome is really fast there, Firefox is faster, and then you read that. And you might decide which browser to use based on which browser is faster. And we want you to use our browser, so we have to go and make our browser faster. So a couple years ago, when Chrome came out, they released a new benchmark. It's called V8, or V8 Bench. It's actually a really terrible benchmark. So it doesn't really represent what the web does, but it doesn't really matter. The press started benchmarking with this benchmark. So Chrome was out, there's a benchmark, we were really slow on it. So on the left side of it, that's August 3. August 3, you could see that we were really slow. So Safari and Chrome were somewhere between like 2,000 and 3,000 milliseconds. We were taking 7,000 milliseconds. So we were twice as slow as Chrome. That's really bad. The press is going to say, wow, Firefox is really slow on this benchmark. It didn't really matter much, actually, in practice. Like, the web wasn't really slower because of the benchmark, but it doesn't really matter. The press is saying we are slower, so we have a problem. And you can see that within a very short amount of time, between August 3rd and October 8th, we basically invested a ton of engineers. We had 20 or 30 people working on this day and night to make us fast on this benchmark, and we very quickly got to the point where we're as fast as everyone else. So this is why the web is moving this fast. This is why the web is so cool. Because every time we are slower anywhere, we are under pressure to fix that. And this applies to everyone else. So every time we come out with a performance improvement and we start being faster than Chrome, then Google has to do this. Google has to send a bunch of people and build their browser to make it faster. So there's a strong competition between these browser vendors. Everyone wants you to use their browser, so we all have to make our browsers better. But the nice part is that we are not doing that by adding some like random Mozilla-specific or Microsoft-specific stuff. Instead, we are all implementing the same standards, just better. So really, the competition is not about who has the strangest ActiveX implementation that's the most proprietary, but who can implement the same open standards the best. So this is really great for users because you get a really fast browser out of it. And it's also really great for developers because they don't really have to target any of these specific browsers. They just target any browser, and it's really fast for them. So this is a desktop. This is really cool. On desktop, this has worked fantastically well. So over the last 10 years, pretty much the reason that you have all those browsers to choose from is because Mozilla over the last 10 years has worked very aggressively on make standards. So most of the standards that you know today, like HTML5 and many of the W3C standards, we had a really big role in creating those standards. And of course, the other browser vendors work with us as well. So we pretty much, the fact that we have competition today from Safari or Chrome, we basically created that for ourselves. So today we have to compete with Chrome, which is a really cool browser as well. And that's, on the one hand, of course, competition for us. For us, it's harder now to build a browser that you want to use, but at the same time, this is exactly what our mission told us to do. We wanted to have you to have choice, and now you do. So on desktop, this worked really great. Over the last 10 years, the desktop has become an environment where the operating system on a desktop really doesn't matter much anymore, right? Whether Windows or Mac, most of the time you spend in a browser anyway. So the operating system is becoming a bootloader. It's the thing that starts your machine until you can open the browser. And over the next couple of years, it's going to get even more so. And this really makes the notion of the operating system and native APIs like Windows 32 or Cocoa on a desktop pretty much irrelevant. As long as you have HTML5, you don't really care. So that's cool. That worked very well on desktop. Now let's compare this with smartphones. Everyone in this room here has a smartphone on them. It doesn't even matter which smartphone you have, they actually all work the same, and they all look very different from the desktop, unfortunately. So let's look at Android, for example. In case of Android, the web is on that phone, but it's not really an important part of it. All the critical stuff actually is pure Google technology. So the platform for Android is Java, but not just any Java. It's like a special Google magic sauce, Dalvik Java. And the APIs on that platform are all defined by Google. So some Google engineers behind closed doors decided what kind of APIs you should have. And if you make an application for Android, you can only use that on Android because it uses Dalvik and all that Google magic sauce. The same is true for Apple. If you have an Apple iOS phone, they have basically the same thing. So you have an Apple platform. It uses Objective-C, which is a really terrible language. And in addition to that, it uses all sorts of Apple technologies, like Cocoa, right? And that's really bad, because if you're a developer, you have to write an Android application, because half the phones are Android. Then you have to write a completely separate iOS application. It's completely separate from it. And then Microsoft was like, I want one too, so now there's Windows Phone 7. And they have, again, a completely different set of tools to use. You have to use C# and XNA and some other like horrible Microsoft technologies. So this is basically exactly the opposite of what's happening on a desktop. On a desktop, all that native cruft is going away, whereas here on mobile, it's coming back. And it's basically the main way of interacting with these devices. And that's really crappy for everyone, like everyone who is not Microsoft, Google, or Apple. It's really bad for you. And I'm going to explain to you a little bit why I think that. So first of all, this is really bad for users. If you buy an iPhone, for example, you buy Angry Birds on iPhone, then you are stuck with that. If you want to keep that Angry Bird version you paid for, you have to stick with Apple. If you buy an Android phone, you cannot simply take the application with you. There's at least several reasons why you cannot do that. So on the one hand, that Angry Bird application that you installed is written in Java and Dalvik and some Google technology. So it just simply doesn't run on an iOS phone. So that's the first problem. But then second, and this is actually even more important, on these phones, it's not just the technology that's owned by these different silo holders, it's actually also the stores and all the services on the device. So your Angry Birds version you bought on Apple, you bought from the Apple Store, which is very separate from the Google Store. So you have a relationship with Apple there. You bought something from Apple, not from Google. So you cannot simply take it to an Android phone. So for users, this really means that once you buy an Apple device or an Android device, you are stuck with it. You cannot easily switch because all your applications and all your data is not portable. And data is actually even more important. On iOS, like all your contacts and all this stuff is stored in your iCloud. In Google, it's stored in your Google account. So once your data disappears in this vendor's silo, it's very hard to get it out of there. So this is, of course, bad for you because you don't have choice anymore. If you ever bought an iPhone and started using it, that's it. You're an iPhone user for life. You cannot easily get out of that silo. That's really great, of course, for Apple, right? They like that. You keep buying iPhones. And the same is for Google. Google likes it because you keep buying Android. But it's really bad for you because you have much less choice suddenly. But actually, for developers, on the other hand, this is about equally bad. Because developers, as I already said previously, they have to target the applications for all these different ecosystems. You have to write an Android app these days. There's so many Android phones. You have to write an iOS app. Those are the best phones. People want to use them. And then now Microsoft wants to make you write a third one for Microsoft Phone as well. So developers really don't like this because they are locked into these platforms. They have to invest and they have to build everything 2 or 3 times. But actually it gets even worse than that because the stores on these devices are completely controlled by the vendor. And the terms of these stores are often really terrible. So in case of Apple, it's pretty much highway robbery. They take like 30% of the revenue of app developers. And especially magazine publishers who like to publish magazines to phones and tablets really don't like that. So once you have created this kind of silo, you have locked in developers and users as well. But it turns out that actually the other 2 parties that participate in this ecosystem of smartphones, which are operators that do the networking part, and the OEMs that make the devices also equally suffer from this. For the operators, what they really lost in this game is they lost the relationship with you. A couple of years ago, when you bought a phone from an operator, you had a relationship with the operator. You were thinking of it as a phone of the operator. Today, really, if you ask someone, what kind of phone do you have? They're not going to say, I have like a phone from operator X. They're going to say, I have an Android phone, or I have an Apple phone, or an iOS phone. So people think of these devices as the devices of the silo owners, and the operators don't have contact with you anymore. They're basically they use the term dumb pipe. All they do is just shovel bits to you. And that's not a very good business. They would rather like to do some of the services, like operators would like to do ads, or maybe the store. So all the cool things that you can make money with on this platform, the operators no longer have a part in. They don't like that. The party in this affected the worst is OEMs. OEMs make these devices, and in case of Apple, they're not allowed to make any of the devices. Only Apple manufactures themselves. But even in case of Android, what the OEMs want to do, they want to build devices that are special to them. So HTC wants to build an HTC Android device that's very special HTC. So you like it and you choose it. But Google really likes to control the platform. So with every release of Android, Google is allowing OEMs less and less to change the appearance or the features of the phone. So with the next version of Android, Jelly Bean, basically you can't really change anything anymore when you make devices. You just have to put Android on it and you can change the plastic shell around it. And it's really bad for OEMs because then the only thing they can compete over is price. And competing over price really sucks. You can't make money that way, right? If you try to make everything cheaper, it's not a good way to make money. They would like to have these highly customized devices, offer you cool additional features that's only in a Samsung phone and not an HTC, and ZTE wants to do something entirely different. And they can't really do that in these ecosystems because they have no stake in it either. And this is where it's actually important to note that Android calls itself open source, right? Android is 2 things not. It's not open. It's definitely not open. And most of the time, there's not even source available. So Android, the source becomes available after Google has released the phone, but you can't really influence the way the source develops. For example, it's almost impossible to send any changes to Android back to Google if you're not working for Google. And also, there's really no openness. The source is developed completely inside Google. So it's not really the sense of open source as we mean when we talk about open source. For us, open source means that Firefox and everything we do is developed completely in the open. If any of you have an idea how to improve Firefox, you can submit us a patch, and then your patch will be treated the same as if an employee of Mozilla had submitted it. So these platforms really are pretty much all the same. They're very closed. And this has led to a system where we accept for some reason that it's okay to make these devices with these proprietary platforms. So if you imagine you're a Facebook executive, right? Facebook just had a big IPO, and you're sitting there, and someone comes in and has this great idea. He has this fantastic idea that he's going to build you a Facebook application for Windows 32, right? That's ridiculous. You would laugh the person out of the room. Nobody would ever do that. But if you replace the word Windows 32 with iOS, it's okay. We do that all the time. So why is it okay on these mobile devices to use native APIs when on desktop it's clear to everyone that that's really a dumb idea? Well, we really think that what's missing there is basically standards. So how can we change this? On these mobile devices, for many of the things that you want to do with the device, there's no standards. There is no HTML5 way of using Bluetooth. So that's why everyone went and built the native stuff. So basically what Mozilla set out to do last year, when my research group decided to do this Boot2Gecko project and build mobile devices with the web, is we had decided that we want to use the same strategy that we were using for the last 10 years to make the desktop open and provide you choice there. We want to use the same thing on mobile devices as well, which means it's a two-part process. First, we have to make the standards that allow us to build these devices with the web. And until 6 months ago, you really couldn't do that because most of the APIs were not there. And then we have to actually build a really cool device, just like Firefox. And then with that, we are hoping to change the entire smartphone space. So we are not against there being other smartphones. This is what makes us different. Like, Google really would like there to be only Android. We don't want there to be only Mozilla phones. But you want to make sure that there's choice. You want to make sure that the technology between Apple and Mozilla and Google phones is all the same. So you can take your applications with you, you can take your data with you. And to do that, we need open standards, and we have to actually go and implement it. And this is very important. So the reason that the web looks like the way it is today is not because Mozilla just made standards. Everyone can make standards. If there's no implementation that people want to use, it doesn't really matter. So we actually have to build it. And that's what we've been doing last year. All right, so the situation we would like to get to away from these existing silos is really use the web as a central point of smartphones. So all the key technology on a smartphone should be based on the web. And if you do that, basically you have the web platform HTML5 where you build all the applications with, and we are adding two critical pieces of that. One is the notion of web apps, and we'll talk about that on a more technical level in a little bit. And also, we are defining a bunch of new services for the web, including identity. So currently in smartphones, all these different services are defined as proprietary standards. So Apple, for example, has a certain way how an Apple account works, and Google has a certain way how a Google account works. We think it's very important that we define the web way. There should be a web account, and a web identity, and a web app, and a web store. And only if we do that, then suddenly it becomes exchangeable between these devices because everyone is using the same platform. And again, the goal is not just, Mozilla does not want to make a smartphone platform now and then everyone is only using Mozilla phones. That's not the goal. The goal is that there's one web way of doing things and there's multiple different parties implementing it. So we are very much welcome Apple or Google implementing a web-based smartphone as well. That's very good. That's what happens on a desktop. So that's really the ultimate goal, is to provide a system where everyone can implement these things. But the key difference to today is that we're going to make it possible for other people to also be participant in this. So let's see how this little laser pointer works here. Yeah, you can't really see that anyway. Okay, so amongst others, operators that are currently completely locked out of the system, we can enable them again to participate. For example, your operator might want to run a phone store where you can buy applications. And once it's built on open standards that are defined on the web, everyone can do that. So operators can do it, we can run it. Mozilla intends to run an application store. We think we're pretty good at helping you find and discover cool applications. There might be other parties like Amazon that also would like to sell applications. And then they can sell these applications across all the different platforms. It doesn't really matter who makes the smartphone. If it's based on the web, then everyone can buy those things. So the first key step we had to do for this is provide a bunch of functionality for smartphones that previously didn't exist on the web. We think that the main reason that the web has not been used much on smartphones and people write applications with this native APIs instead is that, to be honest, the web on smartphones sucks. Like, have you gone to websites recently on a smartphone? it's much less of an optimized experience than on desktop. And it's even worse if you're actually trying to use any of these more advanced features of a smartphone. NFC, there's no way to use NFC from the web. Bluetooth, SMS, camera, contacts, all this very essential stuff that makes a phone really a phone, until recently you couldn't really use on the web. So this has been the focus of the first 9 months of this project. Basically, for everything you see up here on the slide, Mozilla went and we proposed a new standard how to do that. So we proposed a standard for web contacts that explains how you can read contacts from your device on a website. We have standards for telephony and SMS, so you can send SMS and make phone calls. And what's important, we didn't just propose a standard, right? Because that doesn't really change much. Instead, we went and directly implemented this. So all these new standards that we have proposed, we have also at the same time implemented. We have implemented it on these Boot2Gecko phones that I'm going to show you in a couple of minutes what those look like. But also, we have implemented them actually in every version of Firefox. For example, we added a battery API. The battery API, of course, is available on these new smartphones we're making. But we have also added the battery API to every other version of Firefox. So 500 million of people now have already access to the battery API if they use the latest version of Firefox. And this is really what makes these APIs get adopted very quickly. So 30% of the web already can read the battery status and can read geolocation and can read contacts. So this is how we can very quickly push technology out there onto the web. So within 6 to 9 months, we have already quite a few of these APIs already in production, in production versions of Firefox you can download. So the goal really is to take these new standards, and what we're trying to build is, we want to build a smartphone device where everything on the device is completely based on open standards. So it's very important that we are not building yet another silo, right? We don't want to build like the Mozilla silo as a fourth one. It wouldn't work for many different reasons, but that's really not what we want to do. What we want to do is build something with the web and build everything based on web standards. So the way actually we did that is that if you look at an existing smartphone system, and I'm using here Android as an example, they all look the same basically. So iOS and Android, Windows Phone 7 all pretty much look the same. At the bottom, there's a device layer. That's the actual like hardware, right? And then there's some sort of kernel on top of that. And in all smartphones actually that we are built today, except for the Windows one, there's a Linux kernel. And then on top of that kernel, there's some native APIs. And this is where things are different. So on iOS, you're using some Apple native APIs, and on Google, you're using some Dalvik native APIs. And then on top of that, these vendors implement the actual user interface. So they're using these native APIs to implement the lock screen, for example, and the home screen. And then the web browser itself is just a native application on top of this platform. And what we have built is basically, we kept, first of all, the bottom two parts of the system the same. So we're not really changing the hardware. We're working with very traditional OEMs, and we basically use the same hardware all these other guys are using as well. And the kernel, actually, we didn't change much either. There's no reason. Like, Linux is a decent kernel for smartphones. There's no reason for Mozilla to reinvent that. So the bottom parts of the system actually are very similar to existing systems such as Android. Where things become very different is the actual native API layer. So as you can see, we don't have that. We don't have any native APIs. When you start this device, it starts the kernel, and it boots directly into the web engine. And it does so very quickly. So this, basically, when you turn on this device, within 1 second, the device is ready to display an HTML5 page. And then the entire device experience itself and any kind of web content that you browse to is all displayed using that web engine. So again, when you turn on this phone, basically within 1 second or so, you're ready to run HTML5. And everything else on the phone, everything that you see, everything that you can touch is implemented using HTML5. So what this means really is that we have to shift a little bit the model. So a few years ago, really, HTML5, when it started and became really popular 10 years ago, it was a document display format. This causes pages to be structured a certain way, right? So many simple pages are, as you can see on the left here, it's just a bunch of images and links you can click on, and kind of like a document, like content you can read. And we are using now the same technology, HTML5, to build applications. And we can use the same technology, but it means also we have to adjust applications a little bit. We have to make applications a lot more interactive. And also we have to take care of things like offline caching and actually making them installable applications. But at the end, we are using the same HTML5 standards to build them. So this leads to this notion of a web app or open web apps. You have already a lot of web pages out there. Many of these web pages already are applications. So there's maps, for example, right? There's different websites you can go to, and you can navigate, and it can print out maps for you. That's clearly an application. That is not just something like this here. This is not just a page with links and images. People already built a very nice maps application. But what's missing is right now on a desktop, you have to enter a URL to go to that Maps application. And that's really not the way people think about apps on a mobile device. On a mobile device, you want to get the device out, and you want to click on a link somewhere, on an icon on your screen. So for this, we define this notion of a web app. A web app basically is just an HTML5 page that is optimized well to run as an application, such as a Maps application. And then we add something to it that we call a manifest. And a manifest describes the name of the application and icon, and a couple other things are necessary to be able to install that. And then in parallel, what we did is we built a store for these things. So Mozilla built a store based on open standards that can host these applications once they have a manifest. And I will show you in a minute what these manifests look like. And then we can offer people the same experience they're used to. So on smartphones, people are really used to, they want to go to a store and want to click on it, and then they want to go and browse through the store and look at content. So if we add a manifest and if we add an API for these stores, then we can basically offer people the same interaction method. And it looks very familiar to them. The difference is that it actually is all open. So anyone can implement the store. So when I'm done with my talk here, you can look up the APIs I'm talking about here today, and you can build your own web store. And you can start building your own web apps. And on any device that supports this, you don't need Mozilla's permission, for example, to install a store. You just make a store. And if users like your store, they can start using it. And if they want to buy applications from you, they can buy applications from you. So we're kind of breaking apart these silos that currently exist on smartphones. All right, so how does this work? So this is a conference about JavaScript, so it's time to get a little bit technical here. So on the right side here, you see this manifest. It's actually a JSON file. And this manifest contains a couple simple entries. So this manifest, in essence, serves two things. It's supposed to help the user find the application, or help a store to help the user find an application, and then also facilitate payment methods if necessary. So here, for example, we start out with describing the application and giving its name, and then we're defining a bunch of icons. And these icon definitions can have different resolutions, and this is basically the icon then a phone would use on the home screen to display for your application. And then there's some information about the developer. So this is some Mozilla internal application that our labs group did, so that's Mozilla Labs. And then you can define who's allowed to install this application. And in this specific manifest, we are saying that only the Mozilla Marketplace is allowed to install that. In most manifests, we would actually expect that this field doesn't appear. So most web apps, you don't really care, right? If you make a web app, as long as people pay the price that you require for it, if there's one, you don't really care who facilitates that. And then we can define additional locales if you support multiple languages, and that's it. So all you have to do is you make this little file, you put it up on your server, and then you have a web app. Now, of course, this is a very basic web app. So it still requires you to optimize your web app to actually be really a good experience on smartphones, and that's what I'm going to talk about a little bit next. So first of all, how do we install these web apps? So there's a couple different ways. The first most important one is that there's a JavaScript API for it. So you can say navigator.moz.apps, and the Moz part is because this is not fully standardized yet. So as long not all vendors have agreed to support the same API, we use the Moz prefix for that. So you can say navigator.moz.apps.install, and you give it the URL to your manifest. And this is going to cause a prompt to appear where the user can say whether he's OK or she's OK with installing the application. And if the user confirms that, then his application is going to get registered in the web engine's list of applications. And there's a couple additional APIs, and you can Google for this on Mozilla's developer network. You can see that there's a couple other APIs. So amongst others, you can check, for example, whether you have already been installed. And you can list applications. So you can see what applications are installed if you have necessary privilege. And this is actually what we're using for the home screen. And even the marketplace itself is completely implemented, even it is HTML5. So the marketplace application you have seen here, this one, actually uses Moz apps to find out what applications are installed in your system, and then can already tell you, you cannot install this right now, it's already installed. So you can use this for the home screen to start applications, for the actual marketplace, and also as a website owner to install the application. Now, the second really important piece is making sure that your application runs well offline, but also it starts very quickly. So if you just add a manifest to your page and install it on your phone, then basically your phone needs to have a data connection at all times so when you start the application. And that's usually not ideal because it can be pretty slow. So there's a standard called appcache, which allows you to specify that if you add this manifest file to your site, it basically tells the phone to cache all these resources locally on the phone. And then when you start the application, it's immediately going to trigger execution of that code, and it's not going to be fetched while you wait. However, in the background, the browser is going to make sure, or the web engine is going to make sure that it updates the cache. So there's actually a JavaScript API you can see at the bottom here that you can use, and you can install an event listener, and it's going to tell you when the cache was updated. So the website can tell when new content is available, and then can trigger a reload so you can take advantage of it. But with this, you achieve two things. Your application works offline. You no longer need a network connection. And it starts much faster, since all the content is going to be on the device already. All right. An additional way of discovering, by the way, is you don't need actually a store. So the browser also looks out for these manifest files by itself. So if you go to the New York Times, for example, and they have a manifest installed, you don't even have to go to the marketplace. The New York Times can check whether the app is installed or not. And if it's not installed yet, it can actually prompt the user to install it. So this is really nice because it means that in the future we can have much more interesting ways of discovering content. We don't just need a marketplace. We can also integrate this in social networks, or if a user is visiting a site you're doing, you can offer to install a couple other apps from other sites. So it's simply a much richer environment. And the last important technology piece I wanted to talk about is browser ID. So one key difference that we would like to do in this system with existing systems is that we want to make sure these apps are exchangeable between devices. And currently, if you have an iOS device, you install the application for the device. And instead, what you want to do is you want to install these applications for the user. So for this, we have proposed a new identity standard called Browser ID, and any vendor can implement that. So Mozilla is implementing it, but also we have already gotten actually a couple large operators of phone networks to sign up. They can all implement this identity format. And then when you buy an application, it's linked to your identity. So if you sign in with your identity into your phone and your desktop, you can use all the applications between all these devices. And it doesn't really matter who is your network operator or who implements this. All right. So the phone actually we have built is using all these different technology pieces that I just talked about. So here you see a couple of screenshots of the user interface, which the code name for is Gaia. It's not really a product name, it's just a code name. But that's what we call it internally right now. So on the left-hand side here, you see a lock screen, the way it looks like right now. And this is all pure HTML5. So when you start the device, the first thing the device does, it loads the lock screen HTML5 page. And everything you see here is just HTML5. So the image there with these pipes in the background, that's actually just an image tag on the background. And in the time, that's JavaScript reading the time and updating that. But even at the top, when you see that little bar there, all the information that's in the bar, so the name of the operator, for example, is all being read from the phone using new HTML5 APIs we have proposed. So there's a network information API now. And there's a signal strength API where you can read the strength of the local Wi-Fi signal and the network signal. And in this phone, of course, we also have a Firefox browser. However, even the browser itself is implemented as HTML5. So we have added a couple new APIs that allow you, in HTML5, to write a browser. So the inside of it, of the browser, is basically an iframe, and then around of that is some more HTML5 code. So the URL bar and the buttons and the menus and everything, it's all HTML5. So everything on his phone, as you can see, is always completely HTML5. I already talked a bit about the home screen. You can see on the left here. So the list of applications on the home screen actually is, the home screen itself is just, again, a background image and a couple of images we load there. And the list of those apps is, again, completely done with this Moz Apps API. So if you install a web app on this device, it appears on your home screen because it's in a registry. And even things like the keyboard, for example, you see on the right here, which is, by the way, done by someone here in our Taipei office, even that is completely implemented as HTML5. So everything on this phone, as you can see and touch, is completely HTML5. All right. A couple of quick pitfalls I want to talk about is you can do very nice-looking UIs with HTML5, but it's very tricky to make sure it also performs very well. A couple of hints that I would like to give you is that there's a concept in browsers called reflow. So if you change a layout property like top or left, it causes your page to be relaid out and repainted, and that's very slow. So instead what we're doing, we're using more advanced HTML5 styling primitives like transform, which are applied after layout, so they don't require repainting. The home screen, for example, if we want to move around with 60 frames per second. For that, we have to make sure there's no repainting. So we use these transform primitives. You should give those a try, because then, basically, we don't have to repaint, and we can very easily and very smoothly move these things across on the screen just as a GPU texture. All right. One thing I wanted to show you before I'm ready to take some questions is this is the latest UI designs I've gotten from the team. So these are just a couple of days old, and this is probably still going to change quite a bit. And you are the second group of people on the planet to ever see this outside Mozilla. So this is basically what our new UI is going to look like. And I'm not a UX person, but from what I can tell, so the orange there reminds me a lot of Firefox. And I really like about our UI also there's a lot of white in there, because the web traditionally is white. Most web page backgrounds is white. So it's really a UI we're trying to make in such a way that it ties everything in that Mozilla is. It ties in the Mozilla brand, but also the web, and the fact that it is a web-based phone. All right. Here's a couple more links if you want to get involved. I just said everything we do is completely open source, so all the code you can find on GitHub. You can find the Gaia user interface itself on GitHub as well. If you want to help, you can help us hack on Gaia. You can write applications for this with the manifests I just showed you. And there's also a couple of phones you can buy, a couple of Android phones. And if you buy those, then you can install BoottoGecko on them. And last but not least, actually, if you want to do this for a living, I heard that Mozilla Taiwan is also still hiring, both for the BoottoGecko project as well as Gaia as well. All right, thank you very much. So I think I have 6 minutes for questions. All right, any questions?
Sorry, I think the B2G project is really cool, but it's totally based on HTML5. But it still have some issue if all the applications are based on HTML5. Because if you develop an application with HTML5, every people can easily get your maybe something you write very easily. And another issue is if we only use some reader or some browsing function, maybe performance is not very big issue. But if we use some game or something, they must have a very heavy computing power. Maybe it is another question.
All right, so actually think of the slide I showed in the beginning, this one here. So everyone we talked to about this, they mentioned performance, right? There is no other system out there that is under as much performance pressure as browsers. Like we are up against Google and Microsoft, two large corporations with a lot of smart people, and we all compete who can run JavaScript the fastest. On Android, how many people implement Android? One company, Google. What is Google's interest in making Dalvik faster? There's none. So actually JavaScript today in browsers is already often a lot faster than Dalvik, the Java language on Android phones. So performance is not ideal everywhere. I already showed you this slide with the transform instruction. You have to be careful how you do these things, and there's definitely a lot more performance work we have to do. But in many areas, browsers are already today much, much faster than Android, the Java environment, Android, for example. So I can show you a couple of benchmarks that we are 5 times faster than the Java execution on Android phones. And the main reason for that is that we are competing. Every day we have to make our engine faster, whereas Google doesn't really have to compete because they have the only implementation of Android. Okay? Any other questions?
Okay, yeah, thanks for a nice talk. Also related to the previous question, my question is about HTML5 does support 3D capability. So is that something that's also considered for the Gaia project? I mean, is it expected that like video playback or 3D display is going to be a fluent experience?
Yes. So both things that you mentioned, like 3D capabilities for gaming and then also video playback, are essential parts of a smartphone. So actually, if you download Gaia, there's already a demo in there that has a 3D skull rotating. And we are working with the OEMs that make these devices to highly optimize the video playback as well. So that we support H.264 video playback and full media capabilities. It's just to expect that. You can't really sell a smartphone if it doesn't play cool 3D games and videos.
And that as developing for desktop, I mean, is it going to be the same as developing for websites as for the smartphone?
Yeah, so that's pretty much the goal. So sometimes people ask, where's your SDK? Where can I download the BoottoGecko SDK? There's really none. Like you have to write HTML5 applications, and there's always a little bit differences. So the latest APIs, they're sometimes a little bit different between like Firefox and Chrome, and There's sometimes small differences, but in general, if you write for HTML5 and for mobile HTML5, it should run on Ubuntu Gecko, it should run on Safari phones, it should run on Android phones. Often on our phones, it runs a little bit better. So our phones are really highly optimized for HTML5. It's the only way we can render content onto the screen. So often we're a little bit faster than iOS, for example, or Android. But in theory, it should be pretty applicable. So and also as these things go forward, there's going to be more and more support in libraries. So jQuery, Touch, and all these kind of abstraction libraries often help you to hide the difference between the small differences between the platforms.
Yeah.
Any other questions? All right. Thank you very much.